broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to Coffee with Caleffi. It's Bob, Hot Rod Rohr. I'm in Missouri today, coming from my home office. I got a good presentation today. I had fun putting this together. This was interesting. I've got a lot of first-hand experience in this topic, so it was kind of fun pulling out some pictures and putting this together, so I hope everybody enjoys it and gets a lot out of it. But we called it filling, purging, cleaning, and regulating hydronic and solar systems. Now, of course, we could add to that geosystems, too. Really, any system that has a fluid in it. Fluid might be water. It might be a mix of different chemicals, glycols or methanols. But the filling and cleaning and the procedure for pressurizing the system is going to be the same regardless of the system. But for today, we're going to talk mainly about hydronic and solar type of systems. Now, filling and purging, I kind of broke that down. Obviously, every system is going to have to be filled. I mean, the only way you can turn on the system you start running is filling it. Purging it gets done pretty much to a pretty good point. I would say most people purge to the point where their pumps are going to work and they're moving fluid and they're moving heat or they're moving the energy through the system. Do they get 100% good purge right away? Probably not. You know, it can take days for all the tiny little micro bubbles to work their way back to, you know, wherever you have a central air purge and come out. So depending on the equipment you're putting in and how much time and patience you have to purge it out when you're on the job with your, you know, with your fill system, you know, I was going to tell you what kind of purging job you have in the end. Cleaning, though, that's the one where I think most people fall down. I don't know that a lot of people are cleaning their systems before they commission them, before they start them up and walk away from the job. And it's an important part of it, and it's often overlooked, and we're going to talk about that quite a bit. What I did notice, we went down to the IGSBA show a couple years ago, the International Ground Source Heat Pump Association. What I found down there, since those systems tend to be pretty big on the commercial systems, is there's usually another contractor that comes in and takes that part of the job. So, you know, the installing contractor, the HVAC, or the mechanical contractor would sub that out on a job and have somebody that comes in with the right equipment, with the right chemicals to put in there and clean it, you know, test the quality of the water, make sure everything's fine. So we'll cover that, and I'll show you some of the things that you can do as a small shop as an installer, some of the precautions you can take, some of the equipment you can use to do that to make sure you're going to leave the system in good condition. And why that's more critical now than it was in the past is, you know, back in the early days when we were putting in cast iron boilers, if you ever broke apart a cast iron boiler to take it out of a basement or something like that, you notice the cast iron could have been up to a 1/4 inch thick in spots. So you had a lot of metal there to give up to, you know, to corrode away and still not have a leak in the system. But if you've looked at a ModCon boiler, a tube type of boiler, or even a tube and shell type of boilers, I mean, you're talking thousandths of an inch thickness in the metal now. So it's really critical that you've got a fluid in there that's not going to be aggressive to that, the wall of that heat exchanger. You're going to have some issues. So we'll start with the steps here that I would go through on a system. Of course, you want to pressure test the system first. I used to prefer to use water, you know, unless it's in a condition where it's going to freeze and you have to use air because you don't want to leave it on the system overnight. If it's outside or if it's a snow melt or something like that, you'd have to use air in the winter time. But water's good because you can flush out some of the dirt and debris that's in there, and it's also easier to spot a leak with water. You know, you'll see the drip on a threaded joint or on a flange connection where you haven't tightened the bolts or something like that. And like I say, you want to get the dirt and debris out of the system, and there's always dirt and debris in systems, regardless of a brand new system that you put in. You can have stuff. I know here in Missouri we get these little wasps. They're called mud daubers, and they'll build little nests in any tube that you don't have a cap on or a piece of tape over the end of it. It sits around very long. These things get in there and they build a little nest, and of course that's going to flush through to your system. And probably on the bigger side of that, we were involved in a job down in Mississippi here recently, a big solar job. I think it was like 48 collectors or more. And that system was put together with welded pipe. It was 2-inch welded pipe. It was underground. They had to go out to a ground-mounted array across the parking lot, and outside there was probably a couple hundred feet away, and it was all welded pipe. So you can imagine when they're cutting that pipe with you know, abrasive saws or chop saws, and then they're welding it and making those joints, mitering those joints and stuff. A lot of that debris is inside there, and you certainly don't want that coming back and getting into your pumps and into your control valves and stuff like that. So a system like that definitely has to be flushed out. And even on a small copper system that you're doing, I mean, you should be reaming your pipe with maybe a pencil reamer. I know a lot of guys nowadays are cutting their copper with chop saws or those little porta band saws, like a little band saw, and that's going to leave shavings inside there. You want to get that stuff out. But the other thing you're going to find inside there is going to be all different components that they use in the manufacturing and the assembly of the boilers and pumps and things when they put them together. There's different lubes that they use to put seals in. There might be, you know, if they threaded any pipe, there might be some cutting oil or something residue inside the equipment. So all that needs to get out. Now, what's in the system?
Excuse me, Bob. we have some reports of low volume, so if you can turn up the volume somehow, I think it would.
Yeah, let me crank it up on my phone here. I'm on my phone, so I'll crank that up a little bit. Does that sound a little bit better? Let me know, but I'll talk louder and I'll crank up my button here. So now when you go to clean a system, the cleaner that you choose to clean it out depends on what you think is in there. Obviously, if it's a new system, we talked about a system that might have some oils or some greases or stuff like that in it, then you're going to have to use like a soap-based cleaner in there, something that, and there's plenty of companies out there that offer hydronic system cleaners that will go in there and clean that out. Now, if you're talking about a retrofit on an existing system where maybe there was some hard water in there, maybe it had a leak in the system and it had been taking on fill water for years and years, that tends to have like a lime scale or a calcium buildup, and the soap-type cleaners aren't going to go after that. You're going to need like an acid-based cleaner to go in there and clean the deposit out of the piping and out of the heat emitters, out of the radiators, whatever the system might have. And there's chemicals like that. For years I've used Hercules makes a product called Sizzle. Again, it's an acid, and they tell you how to mix it that is safe for domestic water use also. So you'll see cleaners like that being used now also in these tankless type water heaters, or if you have plate heat exchangers that if you have to flush out from time to time. That's typically, if it's on a domestic water side, that's typically going to be an acid-based type of cleaner that'll go in there and get that hard scale buildup off of your heat exchange surfaces. But now if you find a system like that and you open it up and you're retrofitting the boiler and you see that you've got some of that white, hard mineral buildup in there, you want to find the cause of that because it didn't go in there, you know, the day you put it in there. So usually you're going to find that there's a small leak in the system. In a radiant system, that can be hard to find sometimes. If it's an in-slab system, you might have a pinhole from when you put the tubing in and you've got a small leak, and that small leak takes on, maybe it's only a couple gallons a week or something like that. But over the years and the months, that's going to add up, and that's where you're going to see that hard water being added to the system and clogging up heat exchangers and putting that deposit on. Any deposit that you get on the pipe or on the heat exchange surface is going to limit the amount of heat transfer you can get. You're trying to get the heat energy from the flame into the fluid, so any little insulative layer that you put on there, be it a hard scale buildup or dirt and debris in there, you want to flush that out of it. And the very final fill, after you've cleaned out your system and you've flushed all the dirt and debris out and you make sure it's leak tight, you want to use a good quality water. And you'll notice that now most of the boiler manufacturers actually tell you, they'll give you a spec on the water. They'll usually tell you what they want the pH to be, the range for that, the hardness. I just put a new lock-and-bar boiler in my own house, and I know they gave me, I think, 3 things in there. They said the chloride's less than 200 parts per million, less than 7 grains on the hardness, and I think there's also a spec in there on the pH. So they're going to give you an idea of what they want because, again, they're aware that these smaller heat exchangers, you know, you've got to be pretty close on your water or things can go bad pretty quickly. So if you don't have good quality water on the job, you've got a hardness test kit. You can test some of that at your own. Bring the water in with you. It's easy to find conditioned water. Even here in Springfield, Missouri, town population about 150,000 people. There's 3 different companies here locally that will sell me water. It's called deionized water, demineralized water, where they run it through a resin bed and it can scrub away a lot of those problems before you put that water in. I just take a 50-gallon plastic barrel down there and they fill it up right on my truck, and then I can take that to the job and just pump it in. And most of those companies that provide the chemicals, Romar's one, I've used RectorSeal products under the Stewart Hall name. I know Fernox is out there. Most of them will offer a test procedure for you where you can send a sample of the fluid in and see what's in the water. I've also used in the past universities. A lot of universities can test for water to see what's in there if you can't find somebody local like a Culligan or a water treatment specialist that doesn't have the ability or want to mess with it. Sometimes you can go to an extension agency or to the university and help them. They can help you with that. And also the last thing that's important, if you're going to use a glycol, I would say use a pre-blended glycol because that's going to be blended at the factory with a good quality water, so you don't have to worry about taking it on a job and the water on the job site isn't good enough and it's going to start to break down some of the inhibitors in your glycol. So use a pre-blended. You can find it out there. It's usually going to be blended about 50% mixed water to glycol, and that gives you pretty good freeze protection in most spots. But you can ask for a different blend. Typically you have to buy larger quantities. When I had the pre-blended glycol that I would buy locally, usually I would buy it in 55-gallon drums because the price went down, and then I'd have it for a few jobs, and they would blend it to my spec, how much, what percentage you want for freeze protection and the additives and stuff they put in it also. All right, now if we're talking about getting the air out of the system, you need flow to get air out of the system. So to push air back to the point where you're going to purge it out, either if you're going to purge it out of the manifold on a little ball valve or something like that with a hose, or if you're going to try and purge it out of your air elimination device, your essential air separator, you're going to need to be between 2 and 6 feet per second. Now that's the velocity of the fluid going through the pipe. Because if you get too low, if the velocity flows down below 2 feet per second, the water moving through the pipes doesn't push the air in front of it and won't push it back to a point that you can eliminate it out of the system, either at your purge valves or back at your air separator. And if you flow too fast, the water and air just kind of mixes. It's almost like a blender, and you'll see this just bubbled air and water coming back, and it's hard to separate the air out of it if you're going through it too quickly. So now if you're going to do that, if you're going to pump the fluid into a system, obviously you're going to need enough pump capacity to be able to give you that kind of flow rate that you can push the air out of it. Now in a small residential system, usually the autofill valve or a small little half-horse transfer pump, if you're pumping a glycol, is going to be sufficient. But if you start doing bigger systems, bigger loop fields on geos or commercial jobs where you start talking about 2-inch piping and stuff, possibly going out to some zone manifolds and stuff like that, you're going to need a little bit more horsepower to give you that kind of flow rate. Most of the time, a half-horsepower pump would work for my jobs, for my small residential jobs. I did have a larger swimming pool pump with a horse and a half type of pump for bigger jobs, or for some of the smaller loop fields in the geo systems, you could get away with that. There's going to come a point where, like I say, on the commercial jobs, the bigger jobs with big-size main piping, you might want to hire somebody to come in that has the equipment, has the knowledge to be able to purge the system out. And they can also filter it. I met one of the companies that I met down at the IGSPA show here a couple years ago was out of Texas, and they go around. That's all they do is they go around and purge big systems, commercial systems, a lot of big geo loop systems, and they can purge up to a 14-inch diameter main. They'll put a 100-micron filter on it so they can get that fluid filtered out as they put it in there, as they circulate it through it. And my question to them, well, how do you know when you've got enough flow to be pushing air out? Because some of these systems, they didn't even know what they're getting into, because the systems were buried under a lawn or a parking lot. They didn't know what size loops they had or how many loops or anything. And what they would do is they'd put ultrasonic flow meters on the piping so they could just see what kind of flow rate. So if they saw they had an 8-inch main, they knew what kind of a flow rate they needed to be able to get up to 4 to 6 feet per second to be able to push the air back to where they could purge it out. Now, one of the piping on the right here I'll show you that you want to be aware of if you start purging is this, if you're using it, this solar flex tubing. And it's a corrugated stainless steel tubing, and it's got a lot of pressure drop in it. And this is one example of the 3/4 solar flex tubing that we sell. You can see here the pressure drop really goes up as the flow rate starts going up on this tubing. The pressure drop really starts to go up. So you've got to make sure that you've got enough pump, enough pressure to move that through there. So that's one that I would be aware of. It's a tough one to get air out of sometimes if you don't have enough pump, and also with all those little ridges and stuff in there, it tends to trap air. So the only solution there is have enough flow going through that to be able to push that air out of it. So the industry agrees that 2 to 4 feet per second. That Purge Rate company that I met down there at the IGSPA show said they'll go up to 6 feet per second is what they like to run for their velocities when they're purging their big systems. And, of course, it's going to depend on the size of the pipe that you're trying to purge out, the slope of the pipe. It's really hard to push air down a pipe, down a vertical pipe. Think of a 2-inch pipe that's coming down from an upper level, and you're trying to push the air ahead of the fluid as it comes down there. You've got to have enough flow, so to speak, to plug the hole in the pipe that you're going to be able to push the air back down with. What can help you with systems like that is being able to isolate it and break it down into small pieces instead of trying to purge the whole job at once. The more isolation valves that you can put out at your heat emitters or at your manifolds where you can, zone or close off different loops and just do one loop at a time, that's going to help you purge the circuits. And just it's a time-consuming job to do this properly. And I think what happens on a lot of jobs is guys don't allow enough hours at the end of the job to do this, all this where you have to go back, you put a chemical and you go back a couple of days later, you have to flush it out, you have to go back and repurge all those loops. So take the time and do it right, because it's, you're protecting the investment for your homeowner, and certainly the callbacks of a no heat call in one of the loops with airlock or something like that. And here's another example when we start talking about the geo loops, and we start talking about larger diameter, large bore piping, maybe 1-inch diameter high density PE polyethylene tube here on a big geo loop system. You're going to need to get about 6 gallons a minute through that. And that size loop there is going to present about 20 feet ahead. So you're going to have enough pump that you can get that flow rate and overcome that pressure drop, and to be able to push the air out of those loops. So As I was doing some research for this presentation, I came across one of the, at the IGSPA site, one of the click-ons there was they did some really good studies on purging and some really good test data there over the course of years that different people had contributed to this little blog that goes on there about it. If you have time, go to that. We'll send you this link if you want these slides or something. But there's some really good reading there about velocities and purging and some of the problems that you come into. Because that's what's going to show up, and certainly in a heat pump system is in the summertime when we're under cooling load. You're going to say, gosh, it's not cooling properly. It could be you just got some loops that never got purged out properly at the day one, or have some air bubbles in them. If you don't have this program, at the end of the session today, go over to hydronicspro.com and look at this and buy it, because this is a great little program, and I use it a lot for a lot of different things, not only for designing but also for troubleshooting. The toolbar you can see here across the top, it'll do a heat loss calculation, some different sizing for baseboard, expansion tank sizes. But this one here, the fluids, is going to be important. I'll show you that. But I like the pipe sizer one here. And what you can do with this is, let's say you've got a system that you want to purge out that you put in. You go, well, what kind of flow rate do I need? How am I going to get that velocity up around that 2 to 4 feet per second? So I put a little example here of a system that we're filling it up with just basic water. It's copper pipe, 4 gallons a minute flow rate through it. You can even put the temperature of the water, because the temperature is going to make a difference. And you can see what's going to happen here now down in this table here with 3/4 pipe flowing 4 gallons a minute of water through it. You can see what our velocity is going to be up there around 2.5 feet per second. So that's going to be sufficient. I'd like to see that a little bit higher, but that would be enough to push the air out of the system. So you can play with that. And also look at all the good information it gives you over here. So it's going to tell you what the head loss, what the pressure drop is per 100 feet of 3/4 pipe. So if you know how long your loops are, if you've got different size loops in the building, you can add all that up. You can calculate what the pressure drop is, and then you can use this little program here to make sure that you've got enough velocity going through that to push the air out of it. It's a great little program. The whole software is great, but I really like this module in it. Now, different ways that we fill a system. Manually, you can pump it in with a, like I say, a little transfer pump, or you can use an autofill system. If it's going to be a water fill system, you want to put just a valve that's going to maintain the pressure. It's going to fill it and also maintain it when you walk away from it. So I'll go through a couple different options for doing that. Manual fill systems. Now, manual fill is typically when you're going to put a chemical or a glycol in the system. Obviously, it's not going to come out of the water pipe in your house, so you're going to have to pump that into a system. Now, small systems, you might be able to do that with a little hand pump. I'll show you some of the pumps that I've got that I've used. I make up a little assembly of different size jumper hoses, wash machine hoses, different hoses I've built with different connections on the end that I can get into the system and pump it in and also purge it out. One thing I'll caution you about, if you're doing any solar work, a lot of those prepackaged solar pump stations will have a European-style hose fitting on them. It looks a lot like a standard garden hose thread, but it's a little bit shallower, and a regular garden hose fitting, as we know, it doesn't always seal on those. Sometimes you can cheat them a little bit and put 2 gaskets in there and they'll tighten up, but it's a shallower socket that they're having their hose fitting, so it can be a little tough to seal that up. I've got some little adapters I built that when I come across one of those, I just put a little metric garden hose adapter on it so I don't have a leak. Because the worst thing you want is to have the glycol start spraying out as you start pumping it in, because you're not sealed on the fill valve. Another tip, and I'll show you some of them here in a second, some clear plastic hoses are nice for purge hoses, so you can see what's coming out of the system. If you see there's a lot of copper debris, little copper shavings, you can probably assume that somebody cut it with a bandsaw, with a hacksaw, or maybe a chop saw, and some of that copper shaving was left behind in the system. For your typical residential job, a 1/2 or 5/8 hose is fine for purge and fill hoses, and that's what a typical wash machine hose is. A really handy hose to have in your truck. Have a bucket full of those for using for filling and purging out. Now, if you start doing the larger systems, you start getting into some of the bigger loop fields or even bigger radiant jobs, you're going to have to start looking for some larger diameter. Not only do the tubes that you're going to put the fluid into the system need to get larger, but certainly your connections, instead of just a little 1/2-inch boiler drain or a 1/2-inch ball valve, you're going to now have to provide some bigger connections to be able to put a bigger size hose in there so you can get enough flow through there to be able to push all the air and the dirt and debris out of the system. And this is the simplest little kit that you can put together. Just take a 5-gallon bucket. You can buy buckets if you don't have some from the glycol. Typically comes in a white plastic bucket like this. And then what you can do is you can purge into that bucket. So when you first start filling your system, start purging into that. There you can see a clear hose there on the bottom. That one actually has some of those European-style connections on it that are a little bit different size. But also this gives you a place that when you go to leave the job, you just stuff all the hoses back in the bucket so you're not dripping the whatever you pumped in the system out as you go through the owner's building or through their home. It's really handy to have, and also you can flip it over and sit on it so you can watch what's going on as you're purging through the system. A couple different pumps that I've got that I've used over the years. These are little hand pumps. Now, if you have a small system and you're just putting a couple gallons, maybe up to 5 or 10 gallons of fluid in the system, you can do that with a hand pump. You don't need to buy a big, motorized pump to do that. Probably one of my favorites is this one over here on the right, and I got that through Silver King. And Silver King is another company that manufactures different treatments and chemicals for hydronic systems and steam systems. And they make this little suction pump, they call it, because actually you can pump fluid into it, or you can use it to pump stuff out of like a toilet or a sink or something like that. If you got to clean a drain, you can actually suck the fluid out of it too. But what I like about this one is a really nice quality. It's all brass construction. You can see I put some hoses on it. I actually crimped the hose on there. I put a little shut-off valve up on the top, so when I get it up to the pressure I want, I can shut it off. And I put a long hose on here so I can stick it right into the bottom of a 5-gallon plastic bucket and pump it right down to the bottom and then pump it in there. A couple things I learned about this pump is when I bought this, we had 3 trucks and different guys were using this, and I went to use it one day, and I started to move the handle up and down, and the thing jammed halfway down. And what I learned is it's a soft brass chamber on the outside of that, and apparently something got dropped on it, or maybe it got thrown in the truck, and it put a big dent in the side of it, and you couldn't stroke the thing up and down anymore. So we ended up getting a new one. And the next one, what I did is I took some just foam insulation and put it around it so that it protected that. And the same thing on the stem there on the handle. Also, you can see a piece of old heatway hose on there that protects that stem so it doesn't get dented. But that's a handy little pump. You know, it moves pretty good flow, and it'll fill a system. A couple of other things that we offer here from Caleffi is this is a really nice fill and purge valve that we've got in our catalog. And what's nice about this, it gives you 3 valves in one. So there's a shut-off valve in the center of it, and the flow goes through here. So now what you do is you shut that off, and then you can pump your fluid in here. It'll go up through your system, come back down around the system through your tank or through your heat exchanger, and then you can burp the air out of it here. So it's a 3 valve setup. It gives you the way to isolate it and make sure the fluid goes around the direction you want. Then it also gives you these little caps that you can cap it off, so when you're all done, you put that cap on, tighten it with a channel lock so somebody doesn't come down and think that's a place where you can get a drink of water someday and open it up. I've had that happen where the stonemasons come down and hook up to your glycol system thinking they're getting just regular tap water out of it to mix their concrete, and they're draining the glycol out of your system. So you laugh, but it does happen. Then over here on the right is another little pump that we offer from Caleffi, this little hand pump here. And this is a little handy for filling up small solar systems. If you got 3 or 4 gallons of glycol to pump into a system, this is fine for that. And what I like about this pump is it's got a thread here on the external part of this little shutoff valve on the end here. And it actually, if you take the cap off this little fill purge valve that we offer, there's a thread inside there. It's a BSP thread that you can actually screw this pump right into that valve. So now you're not trying to balance this in 2 hands as you're trying to pump it and keep your hose here down into your bucket and stuff like that. Just screw that right into the valve, and now you can just pump it right here, and it kind of holds it for you. And then, of course, shutoffs, once you get it up to pressure, you can shut it off. This thing, you can actually pump about 60 pounds pressure with it. What it's really handy for is if you're going to go to a job like you should every couple years on a solar system and take a little sample of the fluid out, take your tester with you, make sure the pH is good, check the freeze protection rate, take a sniff of it, make sure it isn't getting going bad and discolor and stuff like that. Well, you've got to pump a little bit back in there if you take a cupful out, and that's what this is nice for. You can just, without having to take a motorized pump or a bucket or anything down with you, just pump it right back out of the container that you sampled it with right back into the system. On that fill and purge valve, you can see the valve is sewn with just the threads on the end of it, and then you can choose whatever fitting you want. So you can go all the way up to a 1-inch sweat connection on here. We'll sell you the unions here with the union nuts on it and the green gaskets, and there's 1-inch sweat, 3/4 and 1/2-inch sweat, so you can build it to whatever size piping that you're working with. We actually have some threaded tail pieces for this too, so if you're doing maybe an iron pipe system where you're threading everything together, we can give you the adapters for that also. Now the next step up, if you don't want to hand pump into a system, you got a little bit more fluid that you want to put into it. This is a handy little pump that you can buy online. I found this little, it's a nicely constructed pump. I think it comes out of Germany here. It's called a Resevoir brand. It's a little paddle pump, a positive displacement. It's got little rubber EPDM paddles in here. What's nice about that, it's self-priming. And it's a drill motor pump. So basically I put some, you can see some garden hose connections on both sides, in and out there. And then I made this little bracket so I can hook it right onto my half-inch drill motor. Now I can hold it with one hand. So now I can be regulating my valves or checking things or operating my purge hose with the other hand while I hold this in one hand. The only thing I did find, it was a little tricky finding, this isn't one by the way, a drill motor that'll go up to about 3,000 RPM, because that's about the speed you want to spin this to get the highest performance out of it. It'll go up to about 7 gallons a minute and about 60 pounds pressure if you can spin it at that RPM. Most of the half-inch drill motors out there don't turn that high, but I did find some. I see Hitachi's got one on their website now that a 3,000 RPM. It's got to have a half-inch chuck to fit the the shaft of the pump here. So that would be your next step up in pumps to pump fluid in the systems. And again, this pump can be used to pump out of if you have a sink or a toilet, like I say, that you've got to replace or change or something like that, you could put the hose on it. So it's got a lot of other uses other than just putting fluid in your hydronic systems or solar systems. Now this is another product that we developed at Caleffi just because guys, when they started doing the solar systems, said, boy, it'd be really nice to have all this on a cart where we could just roll it right into the job, roll it right up to where we're doing the job, and then the fluid's in there already. It'll hold about 10 gallons of fluid so we can take it from job to job. We're not pouring out of a bucket or worrying about tipping over buckets. So we designed this little purge cart or pump cart here. It's nicely made. We had a professionally built cart made to our spec here. That you can see it's got bands that hold the tank in place. It's got a pump mounted down low here, so the low center of gravity, so when you're rolling it up and down or putting it in your truck, it stays put. And then we put a shut-off valve up here. It's got a nice ball valve. It's got pump down here. And the other thing we did is on this valve up here is we put a nice pressure gauge up here. It's a glycerin-filled, stainless steel case, glycerin-filled, 100 PSI gauge. This thing will pump up around 100 PSI. And so what that'll do for you is once you pump your fluid into your system, you can shut the valve off here, and now your gauge becomes a gauge that you can watch and make sure that you don't lose pressure, that you don't have a leak somewhere in your system. So it's kind of a multi-purpose. Not only is it a purge cart to put the fluid in, but it's also a test rig that you can make sure that you don't have any leaks up on your collectors out in your system. And certainly it could be used to pump chemicals or cleaners into your system or just water into a system. If you're on a job where the well hasn't been turned on yet or you don't have water into the system, you could take this and pump your water into the system. So those are in our catalog now. You can see this thing will go out there. Oh, it goes out almost about 13 GPM, and again, it'll go up to about 100 PSI. It's got a nice little half horse, a good quality little centrifugal pump on the bottom of that. So if you're interested in that, give us a call, and we'll hook you up with one of these. And this is actually the pump that's on the bottom of that pump cart. You can see it's a nicely made valve. I had a call. There's a contractor doing a big solar job not far from where I live here, and he said, gosh, we went to Home Depot, bought a little drill motor pump, and we're having a heck of a time getting these systems filled up. You have anything you can help me out with? So I said, well, if you're pumping out of these 5-gallon plastic buckets, which they are, the solar fluid that we sell from Caleffi comes in these 5-gallon buckets, and I'll just make up something quick and run it over to you that you can use. And so I just took that little half-horsepower pump, put a little check valve on the bottom of it, just some stainless steel screen door mesh on the bottom there, and it just sets right on the bucket. It self-primes because as you drop it in there, of course, the fluid pumps pushes right up to the pump. And then I said, now I want you to fill all these systems up to 30 pounds pressure. I said, go beyond that, you could pop the relief valve, and then you're going to blow all this expensive glycol right down the drain or right on the floor. So what I did is I took one of our autofill valves, which we're going to talk about next, and I screwed that right into the discharge of the pump. I set it at the pressure that I wanted them filling these systems to. I took the knob off here so they couldn't shut it off inadvertently. I gave them a hose connection there and took it over and showed it to his guys how to drive the sucker, and away they go. So it can be that simple and that portable. Another little way, if you want to take some fluid along to a job with you, a fluid that can be glycol that you can pump in here. If you have some cleaner or chemical that you want to take a job and you don't want to take a pump, you don't want to take a drill motor or any kind of electric pump, you can actually take just an off-the-shelf expansion tank. This is one of our Caleffi solar expansion tanks here. And just put one of those valves that I just showed you, one of our fill purge valves, screw it right onto the nipple on the top of that tank. And now what you can do is just at your shop pump the fluid that you want to take out, or the cleaner, the inhibitor, the chemical, whatever you're doing on your job, and pump it in there. You can pump 3, 4, or 5 gallons in there depending on what size tank you buy. Put an autofill on there to regulate the pressure. And now just take it out to the job and just hook it right up to the fill connection on there and just leave it on there. What's nice about this, you can leave it for a couple days so you're sure all the air purges out of the system. Go back in a couple days, take it off, and take it back with you. So it's a handy little way to just take a little bit of fluid to a job to refill a system, or to leave it on a job until you're sure all the air is out of the system. This little tank here actually fits inside a 5-gallon bucket, so if there's any drips or any mess, it just drips right in the bucket. I've made a couple different versions of this. There's a small one with probably a number 15 Amtrol tank on that, expansion tank on that. Another little valve you can do if you don't want to use one of these fill purge valves, you can just get one of these little 3-port valves that are on the market now. They've got a little side connection with a hose connection there and a little shutoff valve there. So you just pump this up to, you can pump about 100 pounds in these. I think these things are rated right down here on the sticker at 150 PSI. So pump up to about 100, 125 pounds. Now you've got glycol in there or fluid in there, and then your fill valve will regulate the pressure going into your system. Little cap on the end so none of the fluid will drip out as you go on your way out. And of course, you can supersize that depending on how much water or how much fluid you want to take along to the job with you. Here's one. I think that's a 20-gallon well tank. I added one more component to this one when I built it, and I put a little water meter on here. So what I can do with this, if I'm filling a system for the first time and I want to know how much fluid it's going to take, because I'm going to have to come back the next day and put glycol on it, maybe a solar system where I'm going to flush it out, you can put that meter on there and then just see it's a really accurate meter. It'll read down to about 1/10 of a GPM, so you can see how much fluid goes into the system. So when you come back the next time, you've got enough glycol with you to do that. It's also a nice leak finder. If you've got a radiant job where you suspect you might have a leak in one of your loops or one of your in-slab zones or something like that, you can just put this on the job and leave it for a couple days, a week, or a month or something like that, and go back and you can see how much fluid is leaked out of your system, so you can kind of help see how big of a leak you've got and what you're going to do about it. All right, now let's talk a little bit about fill valves. So far we've talked about systems where we're going to pump the glycol with a hand pump or some kind of powered pump. But now if you're filling a system with just basic water from the job site, you want to have some kind of valve that's going to not only fill the system up quickly, but also maintain the pressure. So as air eliminates out of the system when you first fire it up and the boiler heats up, certainly some of that air is going to come out of the solution in there and it's going to vent out. And of course you want to replace that with fluid so you don't have a low pressure condition and have a lockout in your system. So if there's one valve that's probably my favorite valve of everything Caleffi makes, I would say it's our autofill valve. I'm calling it the gold standard because there's none other like it. It's a very unique and it's a very user-friendly valve. And the first thing I like about it is on the very top of it, you can take a screwdriver, you can take the edge of a coin, a quarter, or a penny, or something like that. And what you do with this autofill valve is you set the pressure that you're going to fill your system to. Let's say you're going to fill your system to 15 PSI. You just take and you set that at 15 pounds pressure, and that's all you have to do with this valve. It's going to be as accurate, in fact, more accurate than a lot of the gauges that you see are shipped on the boilers these days. So if you know you want 15 pounds, set it to 15 pounds, and it's going to maintain that pressure. The other thing about this valve, it's a very fast filling valve. It'll fill up to about 5.5 gallons a minute. As long as you have about 30 pounds pressure or more coming into this side of it from your water system in your house or in your building, it's going to fill about 5 gallons a minute. So it's a very fast filling valve. We also put a check valve in there on this side of it. On the discharge side right in here, there's a little check valve in there. It doesn't pass code for a backflow preventer, but it is another level of protection to keep the fluid from backing out of your system back into your water. It's got a shutoff valve built into it right here, this gray knob at the bottom. You turn that in clockwise, and if there's a little shutoff valve in here, so if you're of the opinion that the valve shouldn't be left down when you leave the job, you can use that as your shutoff valve. It's a little stealth, I call it, valve, shutoff valve, because the homeowner doesn't recognize that as a ball valve, so they're not going to go down there and turn that on when you don't want it to be turned on. It's rebuildable, comes apart very easily here. Put a channel locks on that, take the top off. There's a nice strainer around the whole diameter of this, so it's got a big, lot of surface area strainer in there. So any dirt and debris that comes in through your fill system that got through your piping in the house and stuff like that, we're going to catch it before it gets into the regulator, into the diaphragm here, and into the valve shutoff down here. So take it apart. You can replace the cartridge. You can clean out the strainer. And it's available in a sweat or threaded version over here. We also have it put together with a backflow as a combination system. I'll show you in the next picture. But here's what's so nice about this valve compared to some of the others on the market. It's a much faster filling valve. You can see down here we're about 50% faster than a lot of the other valves that we've tested that are on the market now. So that's going to allow you to fill the system up a lot quicker. But also notice that the fill rate stays really consistent on this valve. So as the pressure in the system starts coming up, you start filling at 0 pounds pressure. As your pressure starts coming up, notice that our valve stays out here at a pretty high flow rate. We're still at 3 gallons a minute, even if the system pressure is starting to get up to 10 pounds. Let's say we've got it set for about 14.5 pounds fill pressure on this job. You can see that we're going to fill that at a fast rate. So what that means is you don't have to build a bypass around this valve to get a fast fill that you're going to have to turn that on and forget about or risk popping your relief valve because you weren't paying attention to it. Just set this valve at the pressure you want. It's going to fast fill by itself. It's going to know when to shut off when it gets to the preset pressure. So it's a great little valve. If you haven't tried one, get out there and grab some of those and put them on your jobs. Now, one of the things that we brought that valve on, guys said, well, on the commercial jobs, we'd like to have a little faster flow rate because, we've got a lot of piping to fill. We've got a big building to fill. Can you give us a bigger version of that? So we did. We came out last year with a 3/4 version of that, which will fill almost twice the rate of the half-inch, so it goes up to about 9 GPM fill rate. We put a gauge on this. It's a little bit different design. We don't have that set it and forget it knob at the top here, so you're going to have to dial in the pressure by watching the gauge, and you can see right here you can increase or decrease the pressure. But again, it's just going to give you a faster flow rate. It is available with the sweat or threaded connections and also available with we've got a 3/4 backflow preventer that's available to match up with that. All right, so we're going to fill a system. We've got a new job. We just put a boiler in this house. How much pressure do we have to put in the system? Well, how do we know when we've got enough pressure in the system? Well, what the pressure that you're filling the system with does is it pushes the air up to the highest point in the system so you can evacuate, but that's what gives you the static fill pressure, is the pressure that you're putting into it. You're not using the pump. Your circulating pump isn't putting the pressure in the system. It's the water or the fluid that you pump or pipe into the system that is giving you the static fill pressure. So how much do we need in the system? Well, we want to always have about 5 pounds pressure at the highest point in the system. So this would be, let's say that we've got a 2-story house example here we'll use. And we always want to have about 5 pounds pressure at the highest point. And a couple reasons for that is, let's say we've got a system where we've got an air vent up here. Maybe we've got like a flow type of air vent or even one of those little hydroscopic vents like Caleffi makes. We want to have pressure on that so we make sure that when that flow floats up, there's enough pressure to seat off so we don't have any leak or any drip out of it. So we're going to use the 5 pounds at the highest point pressure in our system as our number here as we work through this formula. So here's the formula for figuring out what your static fill pressure needs to be. Let's say we've got a 2-story house, so from the bottom in the basement here where the expansion tank is mounted to the top uppermost point in the system, let's say it's a hydronic system with a baseboard up there, we've got about 20 feet. So what we want to do is we want to use this formula right here. So P is the pressure that we need to fill it to. What we really need to know is the density of the fluid that we're going to put in there. If it's water, if it's glycol, it changes a little bit. I'll show you that here in a minute. So density divided by 144 times the height of the building. H is the height, and there's that 5 pounds that we want at the top of it, plus 5 pounds. So if you put that in the formula, we've got a 20-foot high building times 4.33, plus the 5 pounds that we want at the top point here. So that's going to give us a 13.66 psi fill pressure to make sure that we've got the 5 pounds on this 20-foot of lift here. Now, what most guys will do with this formula is they'll round that point 433 off the 5 just to make the math easier. It's really easy to do it in your head. If you've got a 20-foot high building times 0.5, you need 10 pounds plus 5 gives you 15. So round that up to 0.5, and that would give you 15 pounds. So you can see there's very little difference between the 13.66 to the 15 psi. So that's what your fill pressure needs to be for that job. Now, again, going back to the Hydronic design software program that I showed you earlier, they've actually got a fluid table module in here. So if you are going to use a different type of fluid, in this example I put a 50% propylene glycol. We're going to fill that at a temperature of 50-degree fluid temperature. You can put the temperature, you can type, there's different types of glycol. You can ethylene glycol, propylene glycol, different percentages of mix in there, and I'll tell you what that is. You can see it changes a little bit from water. We've got 64.8 here, where the density of water at 50 degrees is 62. So it doesn't make a huge difference in this example here. It went from 13.66 to 14 psi, but that table is available for you to use so you can get that dial right into the exact number. So pressure, let's talk a little bit about pressure, why you want to use it. I got some little Star Wars quotes in here. So a couple things that it does for you is you fill that up, you get that 5 pounds positive pressure at the top of the system. Certainly it's going to help you find the small leaks. If you got a threaded leak or a solder leak, solder joint leak somewhere, the pressure is going to help you determine where that is and find it. But the other thing that pressure can do for you is it can elevate the boiling point of the fluid. And I learned this lesson when I went over to Europe a couple years ago, and I was looking at some solar installations over there, and we went around to some commercial buildings over there, and I noticed the gauges. Of course, they read in bar over there, but I'm looking at these gauges, and these systems were reading about 4 bar, which is about 15 pounds per bar, so that gives you about 60 pounds fill pressure on these glycol systems. Gosh, that's odd. Typically we fill a system up, on a residential system, it's going to be somewhere between 15 or 20 pounds, depending on the height of the building. And they said, well, the reason we do that is we try and get our boiling point of that fluid up. So the more pressure you put on the fluid, the more you raise the boiling point of it. So that's another reason for doing that. Another reason for increasing the pressure on the system, if you got a problematic air elimination problem, sometimes just putting another 5 or 6 pounds static fill pressure on it can help you. What it'll do is just squeeze those bubbles, and it'll help them come together and move back to the point where you can eliminate them. Some guys that are having the problems with a multi-story building having trouble getting the air out of it, they'll sometimes go back and bump that fill pressure up a couple pounds until they get all the air out of it, and then set it back down to what they want it to be at. This is another handy little website over here on the right-hand side, this engineering toolbox, and I just put an example of, the boiling point of water at different pressures. You can see over here, obviously, at 1 atmosphere, which is sea level, water boils at 212 degrees, and you can see as you add pressure to it, the boiling point goes up. So, now, the other thing you're going to have to keep in mind is when you pressurize your system and you fill your system is the expansion tank that's on there needs to be adjusted to the fill pressure also. And you're going to want to do that before you pump the fluid in or before you turn the fill valve on and fill it. Do it before there's any pressure in it. Just take a little accurate pressure gauge and check the expansion tank pre-charge. Now, most of them on the side of the tank, they're going to say 12 pounds fill pressure, but they're not always what they say. So I would just find one of these little gauges. I actually bought this one right here, the Auto Parts. And what I like about this, it's a low pressure gauge. You can see it goes up to 15 pounds. So it's going to be more accurate at these lower fill pressures. So if you've got a 60 or 100 pound air test gauge out in the glove compartment of your truck, it's really hard to read the difference between 11 or 12 or 15 pounds pressure on a high pressure gauge like that. So get one of these here. When I go to replace this, I found a little bit nicer one online. This one goes up a little higher pressure, goes up to 20 psi, and it looks like it's got a little rubber thing around it because mine, the glass is already broken on. It's getting pretty beat up. But you can find these at your local auto supply places. Another thing I like about this one here and also this one, you notice it's got a little push valve on the side of it. So you put this on your expansion tank, and let's say it goes up to 15, and you're going to fill your system to 10 or 12 pounds pressure. All you have to do is push that with your thumb there, and it'll let the pressure off. So what you can do is just keep bleeding it off until you get it exactly where you want it. So you're not taking it off, pushing the stem in, putting it back on, and going back and forth that way. This one actually has a little rubber hose on it, so you can, if you have to reach up in between the raft or in between the joists or something like that where you can't get the gauge in, it's got a little bit of a hose on it. So check that pre-charge, set it to whatever your fill pressure is going to be. The example that we had just above there, again, is going to calculate the fill pressure is going to be. This is going to help you check to make sure that your tank is pre-charged. And that's really important on the solar tanks, the Caleffi solar tank that I showed you earlier. Those come for some reason with about 45 or 50 pounds pressure in them, so you certainly don't want to put that on a system and only fill it to 20 pounds pressure, 30 pounds pressure, because you're not going to have much expansion room if you've got your air charge in your tank that much higher than the fill pressure. So I want to talk about another device, the backflow prevention. Now, this is required in most places. It's a code-required device that goes on any application where you're putting boiler water in. Certainly, if you have glycols or chemicals that you're putting into the system, you want to make sure you've got the right listed backflow preventer so that if there was a low pressure condition in the house or in the water system, the public water system, that those fluids can't go back into the water system. So typically what we're going to use is what we call a double check valve. This is called a dual check backflow preventer. And I want to show you how these work because these can have a tendency to drip sometimes, and I want to show you how they're built inside and what causes those to leak, what you can do to prevent that, and how you can service this because this is a valve that we do have some returns on, to be honest with you. Notice, first of all, that they're threaded down here on the discharge port, and they're threaded because we want you to put a fitting in there and take this discharge down to a drain, ideally, or at least down to the floor where they're not going to drip over the top of expensive equipment and something like that. When I saw these valves installed in Europe, they actually have a little, it's kind of like a little funnel that bolts on the outside of this with a little set screw, and so it gives them a little air gap protection, and they take that right down to a drain. So knowing that these can spit sometimes, the fact that they spit is telling you that they're doing their job. They're protecting what you're intending to be protected by them spitting the water out of this vent. And so when people say, well, it spit water out, well, it might have spit water out because that's what it's supposed to be doing. So, but let me show you how they're built inside so you can understand where the spit's coming from and why it's coming from and what you can do to maintain that or clean it out or repair it so you don't have to just throw them out all the time and replace them. So basically what happens when the fluid comes into this device, as you can see, we've got a port here that goes right to atmosphere because that's where the water that's going to come out of it. It's going to go down to the floor here when it comes out of the boiler here so it doesn't go back in the system. So the first thing that has to happen when the water comes into that, you'll notice there's a little, let's call it a spool inside here. It's this little part right here. So when the pressure comes in from your water system, what it's going to do, it's going to slide this spool and it's going to make a seal right here. This is actually the cutaway end view of an O-ring. I don't know how much of you can see it in the cutaway picture there, but you can see this little brass surface right here is going to slide and it's going to go against this O-ring seal here. And that's the seal that's keeping anything that's going to backflow from here or even from this side from dripping out of your drain. So if this seal right here becomes compromised, then you've got the potential for this thing to drip out from either side here. So this seal is very critical and it's important. And 99% of the time when we get one of these back, there's going to be something that's lodged in this little seal surface, between this little seal surface right here. It's going to be a piece of Teflon tape. Again, it's going to be a copper chip or something like that that's come through the water system that's gotten in here. Now, we are protecting these now. They do have a little strainer now that we built into this little tail piece here. It is removable, and you can clean it out. It's a very small capacity, obviously, because it's the diameter of this pipe here. So they can plug up pretty easily. If you're hooking this up to like an old galvanized water system that has a lot of rust or scale or debris into it, you can plug that strainer up, and you're not going to get much flow through it. And your fill valve, of course, isn't going to fill at that 5-gallon-a-minute rate if your strainer in the backflow preventer is plugged up. So one of the things you want to check after you go to a job on a troubleshooting job is, just take this apart and make sure that the strainer is cleaned out. Some people use it once and discard it, and that's another way of making sure they don't plug up and cause a problem. All right, so we've closed this little connection right here. This spool is closed. It's made the seal here against its O-ring. So now what happens is now the water can flow through there. So it's going to close this first. You can see the spring tensions here are different. It's going to close that first. It's going to make the connection right through the center of this here. So now the water's going through there. It's going to pop open this check valve. It's going to pop open that check valve, and then the fluid's going to go into the system. So as long as there's positive pressure on here, keeping the spool closed, it's going to keep this valve open, and it's going to allow fluid to go into the boiler. This check valve here is going to protect so that if there is a low pressure condition, that the water gets trapped in the boiler, that doesn't back into it. But this here, again, is the problem area, and that's where you're going to have the drips are going to be caused because it's coming through here and it's leaking down through this little seal right here. So what you can do on this valve and pretty much any valve out there, you can actually disassemble them right here with the channel locks and take it apart, and you can just pull this back and you can reach up there and you can get in there and you can take the spool right out, or sometimes you can just reach in there. It's a piece of Teflon tape. You might see it and be able to pull it out. But you can clean that seal surface there just like you do on a faucet washer on your sink. If you got a drip, you take it apart, you see there's a particle of dirt or a little stone or a pebble or something stuck in there, and you just take it out, and in most cases it's going to be just fine. So disassemble it right here, pull it apart, clean that seal surface, and you should be back in business. It is union connections on both ends, so it makes it easy to take it apart. As long as you got a shutoff valve here, you can get this out of the system and get in there and clean it out. Now, the other thing that can make these drip from time to time, and it can be an intermittent drip, and unless you're there when it happens, it's a tough troubleshooting call. But anything that could cause this little spool to jump or to move in here will cause this thing to spit a little bit of water. So if this spool, for some reason, just jumped off its seat for a second or two, what's going to happen is this water that's coming through here now is going to have a path and access to go out the vent. And one of the things that causes that to happen, and I've had installers tell me some little tricks for this, for diagnosing and also fixing this, is a pressure spike or a surge or a low pressure condition out on the main. Maybe there's a fire down the street and somebody opened the water hydrant and the pressure dropped in the main, caused that valve to come off and seal. Well, if that valve does that over and over and over again, you're going to get a little bit of a buildup between that sealing surface on that O-ring and the end of that brass spool in there, and then it's not going to shut off tightly, and it's going to drip, 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 and it's not going to stop dripping until you get in there and clean it out. But the other thing that causes that is if you have a pressure spike or a surge, and if somebody shuts off a valve quickly in a building, and you've got high water pressure especially, like you got 60, 80 pounds pressure, you can actually cause that spool to actually jump in there for a second. It's going to spit a little bit. And that can be caused by a water hammer. And water hammer is caused by a fast-closing valve somewhere in your system. And it's typically going to be like a wash machine valve. When it shuts off, you get that bang, that hammer. Or it might be if you have an ice maker on your refrigerator and that solenoid valve in there closes off quickly, you could have a bang. Or if you have a lawn sprinkler system hooked up to your water piping and it's got solenoid valves, or it's got shut-off valves out there that shut off with a bang, it can cause that pressure spike in there, and it can cause that little cartridge to jump off its seal. So the way that you can handle that is put in a water hammer arrestor in the building. So the best place to do these, I did a little research on these also with Sioux Chief, is one of the brands that's out there, fairly common brand. They say the best place, he said, you could put this right here next to the backflow preventer, but he said, really the ideal place to put a water hammer arrestor is where the hammer is being created. So they make these that you can put right behind your wash machine connection there. You can see here's one that goes right on the bottom of a toilet, a ball cock, because they can cause a pressure spike like that. And then they have these that you can just put inline somewhere. So this can maybe go over to your ice maker or something like that. But if you've got a job where you've got a chronic backflow preventer leak that you go back and you switch it out and you go back again and again and again, something's causing that to happen. They're not all bad backflow preventers, and it's best to find the cause. And I'll venture to say that a lot of times that you've got some kind of condition that's causing the high pressure surge, and then the low and high pressure that's causing that little cartridge to jump off its seal there. So that's one fixer. I've had guys on heatinghelp.com say, well, if you take and you put another check valve in front of the backflow preventer, that check will take up that surge, and it won't cause that the double check or the spool inside the backflow preventer. I'm thinking, but now you've got 4 check valves in a row because you've got one in your autofill, you've got 2 in the backflow, and now you just put a 4th one in there. Shouldn't take that many check valves to do a simple protection. So that's one little tip that I'll give you there. So what do I got here? I got a few more slides. Filling new system, how do you do it again? Air test systems again if it's a freezing condition. If not, water test. We want to use good quality water to flush it with. Again, you can haul the water with you if you don't have it. I'm a big fan of using some sort of hydronic cleaner on these new boilers and new systems that we put in, just because I know there are oils and assembly lubes and different contaminants in there. There's dirt and debris in your black steel pipe and different pipes. So there's a lot of companies that have these hydronic cleaners that typically put those in and run them for a couple hours or maybe overnight or something like that and go and flush them out. They condition everything in the system. It's good for your pump seals. It's good for all your piping and all your heat exchange surfaces, because in addition to cleaning out the chemical or the dirt and debris in there, they put a little bit of a film provider in there, so they coat the inside of your pipe and heat exchangers. I've heard guys say they use TSP, especially on steam boilers, because it leaves your water a little alkaline, which is good for a steam boiler. Dishwasher soap. Really, hydronic cleaner is the best thing to use because it's formulated just for that application, and it's got the film providers and other things in it. Fill and pressurize it, and then, of course, you have to go back and flush those cleaners and chemicals out and then fill it with your good water. Check it one more time for leaks and then fill it up again. Now, here's an example of, I showed you this example a little bit earlier. Let's say we're going to flush and fill a geo loop system, and we've got a big 1-inch diameter, 1,000-foot loop there. We know we need about 5.76 gallons a minute flow rate to be able to push the air out of that, so that equates to about 19 feet ahead. So again, we've got a pump here. Let's say we've got a large enough pump you'd be able to flow through that loop and purge it out. I'm of the opinion that the more you can break down the system, the easier that makes life for you when you go to purge it out. So on our geo manifolds, we offer them with isolation valves. So on this system here, let's say you've got 6 or 8 geo loops, big diameter loops. You want to be able to break that down in a loop by loop to be able to purge it out. And this is in one of our hydronics issues. We just show you the procedure for that. Again, we're pumping out of the container that has the fluid that we're putting in there. We're pumping in the one manifold, we're going out through our loops here, and then we're burping it out here. So in this application here, if you've got a geo system that's manifolded like this, you've got the ability to purge the air out of these loop fields without even having to go in the mechanical room and have to worry about purging all this line capacity out too. So you're breaking into small bite-sized pieces. So go out, purge this out first, or if this is a mechanical room location, purge it out here, shut it off, and now you can purge out this loop here. So now you can break it into a couple different subsystems here to purge it out and make sure you get all the air out so you don't have a callback, or you don't have a condition where one of your loops isn't exchanging the amount of heat because it's got some air bubbles in it. And we show this procedure in our solar training that we do. And there's an example of a solar fill using our pump cart that I just showed you. Again, connect into the valves, built right into the solar pump station. You'll see that little flush and fill valve that I showed you earlier. And that's a procedure, obviously, pump in one end, go down through the system, come back out. You can see with our little solar pump station, it's got little flow meters in there, which are handy because you'll see this little dial. You can see it in that picture, but it'll move up to the flow rate. So now you're assuring that you're getting enough flow through that to get a good purge. And you can see purging back into a bucket or back into the in this case, you can purge right. There's a connection on top of our fill cart that you can purge right back into the tank here. So now you're just going to keep circulating until the air's out of the system and the fluid comes back nice and clean. Another nice system that you can put in is Axiom and some other brands of these out there. I think Xylem, the old Bellengosse company, makes a feeder similar to this. This is something that will hold a couple gallons of your system fluid, your glycol, or whatever's going into it. It's got a gauge. It's got a pressure regulator built into it. And it's got a little electric pump in there. So you just fill the system up with your fluid, plug it in, and it'll maintain the system pressure in there. Another way of doing it, instead of using one of those expansion tanks like I showed earlier, and there's an example of one on a giant. Sorry, I don't have the. Oh, there's the photo credit. Didn't have that the other day. Thanks, Mark, for doing that. Ongoing testing, whatever you put in your system, you want to go back and test it, especially if it's a chemical system or a glycol system. You want to be able to check the percentage of the glycol. You want to make sure that the pH isn't dropping. That's an indication that the fluid's breaking down. But you're going to have the same thing if you start putting hydronic conditioners in there. You're going to find that whatever the conditioner, whatever the product that you put in there, there's going to be a test kit available that you can go back in a couple of years and test that. You might have to go and boost up the inhibitors or something like that. And that's going to be important for factory warranties, not only for your peace of mind and for the peace of mind of the customer's equipment that they just spent that money on, but also maintaining the warranties on the equipment. If they find that it's had aggressive fluid in it, you might get a warranty refusal if you have a problem with a heat exchanger or a pump or something like that. Great turnout, and hopefully this information was useful and I presented it in an understandable and useful way for you. But let us know again. I like the critiques. I like the comments. Let me have it. So thanks, everybody, again, for tuning in today.